Hey ladies, in this video we're going to go through the application questions for 11H, which is focusing on the cosine rule. So I haven't checked how many questions there are. Questions 11 to 18, so quite a few questions to get through. I'll try not to waffle on, so this is a nice quick video for you. I was going to say meeting for you, video for you. Okay, question 11. A farm has a triangular shape with fences of 5 kilometres, 7 and 9 kilometres in length. Find the size of the smallest angle between the fences. The smallest angle is always opposite the smallest side. Well, that helps us because if we didn't know that, going to work. If we didn't know that, then we'd probably be doing all the angles. So that gives us a hint. It doesn't matter what you do, 5, 7, 9. So 5, 7, 9. I mean, you can draw them a little bit better to scale if you like. Now, if the smallest angle is always opposite the smallest side, we're going to find this angle here. Now, with your triangles, when you're working with the sine rule and the cosine rule, label your triangles A, B, and C. Now, usually they'll be labeled for you. They won't always be A, B, and C, but if you're drawing your own diagram, you may as well use A, B, and C because that's what the formula uses. Now, if you want to put your unknown as A, you can, but there's no rule that you have to do that. So uppercase A and lowercase a are opposite each other. Doesn't matter which side you call B. This is B. I'm actually holding my pen really weirdly. I might just fix myself up a bit. Also, lots of planes overhead, so I apologize for the noise. I must be all coming back for dinner or something. Okay, so this is the angle we want. We can just call that theta if you like. Now, in class today, I was saying to some of you who wanted help, sometimes it's easier just to label what you know. So even though it's written on the triangle, just to prevent any small errors, it's a good idea just to write them. So A is what we want. So you can call that theta or you can call that A. Doesn't matter. B is another angle and C is another angle. So we don't know what they are. They're not on the triangle. A is 5. B, the lowercase b is 9. And lowercase c is 7. Now, let's say you thought, oh, let's do the sine rule. Okay, you actually don't have enough information to do the sine rule, and you'd probably soon realize that you didn't have enough information. So if you went ahead and did the sine rule and realized you didn't have enough information for the sine rule, you go in and do the cosine rule. Now your cosine rule, and I'm just going to go back onto this textbook just because I don't want to write down the incorrect cosine rule for you. So if you like, you can write down all 3 versions. This basically just means, well, what are we looking for? If we're looking for side A or side B or side C, but you can see they're pretty much the same thing. And these 3 here are your angles. So if you're looking for angle A, you do cos A, angle B, cos B, angle C, you're using cos C. So we're looking for A, so we're going to use cos A. So I'm going to write that down. It's a good idea to write your formulas. B squared plus C squared. So it's the same formula, it's just been transposed. So transposed just means like rearranged. Okay, so there it is. And then we just substitute in what we know. So cos A, lowercase b is 9, lowercase c is 7, A is 5. God, my son is screaming at the PlayStation. I'm going to have to shut the door in a sec. And 2 times 9 times 7. So 2BC, so 2 times 9 times 7. Now, remember I always emphasize the importance of showing your working out. So here we've done some substitution. It's a good idea to show A by itself. So you could keep all this like that. You don't have to do it all now. But to get rid of cos, we do the inverse cos. And then all this goes in its own bracket. So 9 squared plus 7 squared minus 5 squared all over 2 times 9 times 7. And that's enough working out. You can, if you like, calculate this. Okay, so we can just plug all that into our calculator. just grab my calculator. Here's one I prepared earlier. What am I doing? Okay, let's just do a new document. I was doing quite a few videos today for my year 10s. So we're doing calculator. All right, so we want inverse cos. So we go trig, inverse cos. Now, see how we've got a numerator and a denominator? Excuse me. So put them both in brackets. So we've got 9 squared. You can write 81 if you like. Plus 7 squared, you can write 49. Minus 5 squared. Oops. Excuse me. And then the denominator. Okay, so 2 times 9 times 7, just making sure I've written it correctly. Okay, so the good thing about your calculator, it will show you what you've written. So we just do a double check to make sure it's okay. Now my calculator has put it in exact form. So I'll just go Control Enter and it puts it in decimals for me. So the angle is, excuse me. I'm going to have to shut my door, I think. 5, 6. Was it 2 decimal places? I didn't read what it said. Okay, let's go back to the exercises. Oh, it doesn't say. So we'll just do it to 2 decimal places. Okay. Question 12. A ship left the port P and sailed 18 kilometres on a bearing of 30 degrees. So this is our diagram here. To point A. Another ship left port P and sailed 20 kilometres east. So both ships are leaving port, which is P. So the first ship's gone that way, 30-degree bearing, and the other ship has gone east, directly east, 20 kilometres. Find the distance from A to B. So it's a good idea just to redraw your triangle. Now they've used A, B, and P. I think it's probably just a good idea to put C. Doesn't really make any difference. Now this is a right angle at P. Okay, because this line here is going east, we know that this angle here with the 30 has to add up to 90. So that means this angle here is 60. And this is 18 and this is 20. And we'll just go on and continue labeling our triangle. So A, B, and C. So if you want to identify your values, so uppercase A we don't know, uppercase B we don't know, but C is 60. And then lowercase a is 20. And then we've got 18. And we need to, it's like we don't have enough information. C is what we're trying to find. Okay, so we'll just leave that as lowercase c. Now, like I said before, write the formula out. Let's see if I can remember it. I think I'm good. Oh my gosh. Sorry. 2ab cos c. Okay, so there's your formula. So we're just substituting everything in. So 20 squared plus 18 squared minus 2 times 20. I'm going to run out of room. Times 18 cos 60. Okay, so we've got c squared here. The important thing is that you do the square root. So any show that questions, you need to show everything, not just c squared and then the answer. And don't write c squared equals this equals this. Okay, you need to start a new line. And I might tell you what I mean by that in a second. Now this is tedious writing this, but cos 60. What I was saying before, if I could just scroll over here, I've seen very often when kids get questions wrong on the exams, c squared equals all this, and then they write equals c equals, and then they write the answer, but this is not equal to c. So you can't keep going linearly when you do your equation. So don't do that. Start a new line. And it's c equals the square root of this. And then you put all that into your calculator. Okay, so square root, where are you? Okay, so 20 squared plus 18 squared minus 2 times 20 times 18 cos, oops, we'll do a times in there, cos 60. And again, my calculator is in exact mode, so we'll just put it in. So the length there is 19. We'll do it to 2 decimal places, so 19.08. Sorry, I just had a mind blank. I know I was thinking about leaving that as C. Now, it's very important when you define things. So we've redrawn the triangle. You can clearly see there. But the question is asking the distance from A to B. So I would write A to B equals 19.08. You don't really need to put the kilometres in, but put the kilometres in. You also, and I was just thinking about this when I was doing the answer, think about what your answer is going to be. So let's say we forgot to take the square root of that. So if I go back to my calculator, I wonder if I can, so I'm going to square it, which would be the opposite of taking the square root. So we would get 364. Now, if you forgot to take the square root of C, like we did here, you would get 364. And if you didn't think about your answer, then you're not going to question, well, how could it be 364? If this is 18 and this is 20, how could this possibly be such a big number? So it's extremely important when you're using the cosine rule that you remember to take the square root, but think about your answer, and you should think about your answer for any question. So here, 19.08 looks like a good question to do. And here it says to 1 decimal place, so I might just change that and do it to 1 decimal place. Okay, let's move on to question 13. So a bushwalker walked 12 kilometres west from point A to point B. Okay, so remember when we're drawing a diagram, actually, is this a diagram? I think it is. Okay, so they've already drawn a diagram for us. So bushwalker walked 12 kilometres west, so starting here at A, over there to B. Her friend walked 14 kilometres from point A to C, as shown in the diagram. The distance from B to C is 9. Good. Find the angle at A. So we're looking for this angle here between the paths taken by the bushwalkers, correct to 1 decimal place. Just trying to think if we've got enough information. Do they give us a bearing? Okay, I'm just going to redraw the triangle. So I'm going to think as I draw. And we don't need the angle. Okay, so that's what we want. 12, 9, 14, A, B, C, little a, little b, little c. So A, B, C, little a, little b, little c. So A is what we want. And then lowercase values, what have we got? 9, 14, and 12. It doesn't matter what you label A, B, and C, as long as you're consistent with the opposite side. So A has to be opposite A, B has to be opposite B, and so forth. Okay, so we're looking for angle A. So we're using the cos A version of the cosine formula, and I can't remember what it is, so let's just scroll back up to jog by memory. B, okay, good, I'll remember that. B squared plus C squared minus A squared all over 2BC. Okay, so B squared is 14 squared plus C is 12 squared and minus A is 9 squared. And then 2 times 14 times 12. And then to get A by itself, take the inverse cos of both sides. 14 squared plus 12 squared minus 9 squared all over 2 times 14 times 12. And you just plug that into your calculator. So let's quickly do that. So cos, okay, use brackets to separate the numerator and the denominator. Okay, again, my calculator gives the answer in exact form. We want it not in exact form, approximate form. So A is equal to 39.57. And what is it? How many decimal places? What does it want? One decimal place. 39.6, and you can write kilometres if you like. Then question B, or part B, what is the bearing of point C from A? So we're going from A to C, so we're finding, I don't think I can actually draw on this book, but we're going all the way around. So if I go back to my diagram, which I drew up here, we're finding the bearing going all the way around to here. So we've already found this angle. So we just need to add that on to 180. So easy peasy Japanesey. So 180 plus 39.6. So 119. No, 219. Oops. 219.6 degrees. It's to the nearest degree. So 200. Oh, what am I doing? Just realized I made a mistake. That's not kilometers. It's a bearing. That's not a bearing, it's an angle. Sorry. These planes are distracting me. I'll blame the planes. 220. 20 degrees. Okay. And always, again, check your answer. So we can have a look here. I know it has to be somewhere between, oh my gosh. Good thing I checked, because I was just saying it has to be somewhere between 270 and 360 because I've added the wrong number. Sorry. And I would usually delete, but I'm not going to delete now. So I wonder if you picked that up. So 270 plus 39.6, let's get rid of that. So it's going to be 309.6, which is 310 degrees. That's better. Okay, sorry, girls. Okay, let's move on. All right, question 14. A ship left port A and travelled 27 kilometres on a bearing of 40 degrees. So you can see that here, and the 27, to reach point B. Another ship left the same port and travelled 40 kilometres on a bearing of 100. So down here. Yep. So they haven't actually put in the bearing of 100 there, but that'll help us work out theta to arrive at point C. So here's our, this is B, this is C, and this is A. So see how this angle here is 40, and we know that this line is on a bearing of 100. So let me just double check. I want to, a ship left port A and travelled 27 kilometres to reach point B. Another ship. Yep. Okay. So this angle here is just going to be 100 minus 40, which is 60 degrees. So theta is 60 degrees. And you can also see they've got 80 written there. I don't know why, because they haven't written the 100, which would probably help you more there. But that 80 is just showing this angle from the south line to the line between A and C. How far apart were the two ships when they stopped? So we've got to find this length here. I'm going to redraw my triangle. So this is A. This angle here is 60. This is 27. And this is 49. And label the triangle A, B, and C. A, B, C, B, C. Identify your A, B, and C. Oh gosh. Do any of you have like younger brothers? It's like 12-year-old boy is playing on the PlayStation. Okay, so lowercase a is what we need. B is 49 and C is 27. He's just playing basketball. Like, so competitive too. But we're going to watch MasterChef at 7:30, so I'll be kicking him off. Okay, so A squared equals B squared plus C squared minus 2BC cos A. Substitute in your values. So 49 squared plus 27 squared minus 2 times B, which is 49, times 27 cos 60. Okay, remember what I said before? We need to keep them on separate lines. I hope you're not sitting there thinking, oh, yeah, all right, I'll do that. But girls, I see it so much, and it's such an annoying thing to see on an exam. And I'm talking about further maths exams, because students will write, like, do their questions in a linear fashion, so they keep going across the page. Just start a new line. You know, now we're doing A equals. Okay, show you're working, because so many kids do further maths and we've got to differentiate you somehow. So if you can't write the maths correctly, then, and someone else can, so why should you get the mark, you know, if they can do the right thing? Anyway, minus 2 times 49 times 27 times cos 60. Oops, forgot the 0. All right, so we're looking for a length. Let's think about our answer before we press enter. So we've got a 49 and a 27. And we get a square root of 1,807. Let's just press enter. Okay, so it's good. It looks quite like a reasonable answer. Okay, it's not 1,807. That's what we get if we forgot to square root it. So it's 42.5 kilometers, and I'm assuming it's one decimal place. They didn't ask for a decimal place. Okay, question 15. Just wary of the time. I wanted to do I as well tonight. Okay, but we're getting to harder ones. So let's just talk about number 15, because there's a diagram there, but 16, 17, and 18 don't have diagrams. A battleship B detected a submarine A. So here's the battleship, detected a submarine. There's a bearing of 50, distance 8 kilometers. Cargo ship here at sea was due east of the battleship. How far was the submarine from the cargo ship? Okay, so this one here is your straightforward cosine rule. This angle here at B, remember, is 90. So if we were to do from north to east is 90 degrees. So this angle inside the triangle. So I might just get you set up. So this is going to be 40. We've got 8, 5, and here's B, big A, big C, little c, little a. So I'm just going to write the values for you. B, C. So A, we don't have the angle. B, the angle is 40. C, we don't have that angle. A is 5. B is what we're trying to find. And then you got C, which is 8. Now, when you think about your answer, we've got a 5 and an 8. So it's got to be around there. Okay, so think about your answer. All right, question 15. From a lookout tower A, a fire spotter saw a bushfire B at a distance of 15 kilometres in the direction of 315 degrees. I don't like this pink anymore. I'm going to change. So it was annoying me a while ago, but I thought during a diagram I'll use a new colour. Okay, so here's A. Let's draw our north, because we're doing some bearings here. Now, we're going to be in a direction of 315. So we're going all the way past 270. So we're going to be here somewhere. So I'm going to put my bearing in a different colour. So all the way around here is about 315. And it also told me that distance, which is 15. Okay, so that is A, and this is B up here. A township C was located 12 kilometres on a bearing of 265. Now, it doesn't say where from, but I'm just going to go, doesn't say. I'm just going to quickly look at the solutions, because I don't want to draw the wrong one. Give me a sec. Sorry, had a bit of school box happening. Yeah, so it is from A. So it's on a bearing of 265. So that's just before it hits west. So it's going to go down here. How far is it? So the first one was 15, so it's not as far. So that's 12, and that bearing, which I might do in a different colour. See that in green. So going around to here is 265. And we have to find the distance between the two. Is that right? How far was the bushfire from the township? I was going to say the bush ship from the town fire. Okay, so let's see. So we're looking for this distance here, which we'll call lowercase a. Now, triangles there. Let's just redraw that. So we've got a B, oops, not a B, a C and a B. And this angle in here is just the difference between your two bearings. So 315 take away 65. So what's that? 35 plus 15 gives you 50. We can do that on your calculator if you needed to. Then we've got A, which is what we're working out. Little c is 15 and little b is 12. Okay, so let's just write them down. A, B, C, then A, B, C. So your angle at A is 50. Little a is what we're trying to work out. Little b is 12 and little c is 15. I feel like I'm talking about little kids. These are my kids, little a, little b, and little c. Yeah, they've got an extra week off school because, yeah, anyway, let's just move on. So write your formula. So a squared equals b squared plus c squared minus 2bc cos a. You could put the square root on now if you like. You don't have to. Actually, let's do that because otherwise then we're writing it twice. So we know how to take the square root of it. B squared is 12 plus c squared, 15 squared minus 2 times 12 times 15 cos 50. And then let's just chuck that into the calculator. So we've got the square root. Oh, I probably should have just let you guys do this because I'm just thinking of the length of these videos, but I'm sure you don't care because you're doing it anyway. Some of you probably don't even do it on your calculator. You're like, oh, Miss Milan, just do it for me. So you're probably sitting there thinking, oh, I don't know, no, just do it for me. Sorry about that answer. Okay, so there we go. A is not, oh, now I've gone wrong somewhere because it should not be 179. And I've done the square root. So 12 squared, oh, there it is. Can you see that? I put a times in instead of a plus. So girls, remember, check your answers. I was wondering why the sign was, oh, the sign's there anyway. There we go, that's a bit better. 11.73. Okay, good stuff. All right, let's move on to, what have we done? We've got 17. Okay, so maybe I'll just set up the diagram for 17 and 18. So passengers who are traveling in a car west along a road that runs east to west. So let's draw that first. So there's our road, east to west. Oh, that's west to east, so east to west is the other direction. See a mountain 9 kilometers away on a bearing of 290 degrees. So they've gone from A, okay, so they've gone from east to west. Okay, see a mountain 9 kilometers away on a bearing of 290. So that's north. We're going 290 is just past west, so it's going up like that. Did I not leave myself enough room? Okay, I'm going to rub that out a bit. I did not give myself enough space. Now, I always say to you, oh, come on, eraser, work for me. aren't you working? Do you want to work on this? Oh, let's start again. My eraser's not working. Okay. A, B, there's north. Okay. And our bearing 290 is going up like that. So see a mountain 9 kilometers away on a bearing of 290. So that's 290. They have traveled a further 5 kilometers west. So further 5 kilometers west along the road. What will be the distance to the mountain? Okay, so we're going to find that distance there. So that's 5, that's 9. This is what we have to find. So I'm just calling it X for now because we've already got some A's and B's happening. This angle in here is going to be 290 your bearing, take away 270 because the road runs east to west. So that's going to be 20 degrees in there. And I've done it a bit small, so let's just redraw this triangle a bit bigger. So there's 20. This is 5. This is 9. Now I've already got B here, so I'm going to put B here. Don't worry about that A. So we'll just put A here. That A was just to tell you that we're going from east to west, because it would have been, yeah, weird if you went from west to east. Wouldn't have got the right triangle. Okay, so let's label our diagram A, C, B. Identify what you have. Here I was saying, I'm not going to do it for you, and look at me. B is 20, A is 5. I'm going to stop after this though. And B is little b was what we want to know, and big C is, little c, sorry, is 9. Okay, so you're going to use B squared equals A squared plus C squared, blah, blah, blah. Okay, let's move on to 18. At a point A on the ground, the angle of elevation to the top of a radio transmitter tower is 60 degrees. Okay, so point A, the angle of elevation, so remember angles of elevation and depression, we always go from the horizontal. So at elevation, we're going up, so that's 60 degrees. From that point, a 40-meter cable was attached to the top of the tower. I'm just trying to think. From that point, what point? At A? Is this a cable here? At point B, a further 10 meters away from the base of the tower, another cable is to be pegged to the ground and attached to the top of the tower. So I'm assuming it's on the other side. So if this is our tower, so it's supposed to be a tower. I'll just do it like that. Is that what a power line looks like? Okay. At a point A to the ground, the angle of elevation, so I got that right, 60. From that point, a 40-meter cable was attached to the top of the tower. I'm going to say that's there. At point B, a further 10 meters away from the base. So it doesn't really say it's not that side, but I'm assuming it's here because I can always check the answer. Another cable is to be pegged to the ground and attached to the top of the tower. What is the length required for the second cable? Oh, no. What are you? Okay. I think we've got a few things going on here. I should probably check the question. Let me just check because I just want to make sure I've drawn the diagram. All right. I've just checked the answers and I have drawn it not how it's supposed to be, but I'm also not liking the answers anyway because I'll show you again what they've got. So point A on the ground, the angle of elevation to so we'll call that the tower. So angle of elevation goes from the horizontal up. Oh, sorry, that's not 120, that's 60. From that point of 40 meter, okay, so we'll go with 40. At point B, a further 10. So I think B is here. Okay, so that makes that 10, and that's the length you want. So the triangle you're looking at goes like that. That makes sense now, because they've used this angle here at A is 120, and this is B, and this is C, this is 40, and we want to know the length of this cable, so A. All right, good. It does work. I was just, yeah, but something like that, yeah, you would rarely see, because it says 10 meters away, further 10 meters away from the base. Okay, I kind of understand now. That's the part that got me stumped. Okay, A is 120, and the other two angles we don't have. So little a is what we're working out. And then we've got B is 40, and C is 10. All right, and then you just use the cosine rule. All right, girls, good stuff. Bye.